In this paper, we present a system which uses a Kinect camera to track and infer how the user builds a model from Duplo blocks. The user builds the model in the play area on table. He interacts with the system using 3 control boxes: add, remove, and recheck. The display in front of user provides visual feedback by displaying a virtual model in the same pose as the user holds the real model. The system can be used in 2 modes: authoring and guidance. In authoring mode, the system learns how the user builds a new model. The system tracks the model as the user moves it around in the play area. To add a new block, the user places the new block in the add box first. The system detects its color. The user then adds the block to the model. The system now infers the new block's position on the model. Once the system detects the new block, it appears as part of the virtual model as a blinking block, and a countdown timer is started. When timer runs out, the system accepts the replica with the detected update. If the inferred position is wrong, the user can place his hand in the recheck box. The system then blacklists the detected update and checks again. To remove a block, user removes it from the model and places it in the remove box. The system detects the removed block and shows it on screen in blinking mode. When timer goes out, the system updates the replica and its internal representation. We now show how a model is being built by the user from this state. Once the model has been built, the guidance system can now instruct a new person to replicate the model. At any step, the user sees a virtual replica of the physical model from his viewpoint on the screen. The next block to be added is shown in the blinking mode. The user places the new block in the add box. He then adds the block and moves the model around to let system verify the update. The update is found to be correct and the next instruction is loaded. If the block placed in the add box is of wrong color, the system tells that to the user. The user now uses a correct colored block and adds it to the model. The update detection proceeds as described earlier. This time, user has added the block at a wrong place. The system detects that and shows the mistake on screen in gray color along with the blinking instruction. The user then corrects his mistake and lets the system check once again. On verifying correctness, system loads the next instruction. This process continues till model completion. We compare our guidance system with traditional methods of guiding assembly by static images. We conducted a user study with 16 users and tested 2 interfaces. In the first interface, we show 2 static views of the instruction and ask user to add the corresponding block. In the second interface, we use model tracking, which allows user to move the model around, understand the instruction from different views, and then perform the block addition. We measured the time taken to complete a set of block additions and the number of mistakes made. Our system gives statistically significant improvement in both the metrics over the traditional method. To summarize, we have shown a real-time system which allows users to seamlessly teach a computer how a model is built. This then allows a new user to be guided in the process of replicating that model. A user study showed significant improvements in both time and less mistakes over static step-by-step instructions. Thank you.